People say, oh, Alzheimer's is genetic. Garbage. That genetic component is only 5%. So that means 95% of Alzheimer's risk is environmental. Air pollution, microplastics, ultra-processed food. And a paper just came out showing that sweetener consumption correlates with dementia. And we think we know why.
And you've not talked about this publicly yet?
No, let's talk.
Dr. Robert Lustig is a world-leading sugar expert
who's teaching the world how to reclaim their health from the industry that profits off your vulnerabilities.
73% of the items in the American grocery store are poisoned because sugar is hidden in all the foods. For instance, there's 262 names for sugar, and the food industry uses all of them because they knew when they add it, you buy more. But the problem is, and it's providing people with a dopamine hit, and that dopamine is addictive. And that's when you actually have a biochemical and medical problem. And we have data to show that ultra-processed food has been associated with dementia, diabetes, cancer, every single mental health disease. So the question is, how can you buy healthy food and not be tempted by the bad stuff? So first, if a food has a label, it's a warning label. The second thing, if any food has a sugar in the first 3 ingredients, it's dessert. And then when they go to the store, don't go hungry.
And what about exercise?
Well, it doesn't really impact your desire to reach for sugar. It has its own metabolic benefits. But if you think exercise is going to make you lose weight, you are deluded. And we can talk about that.
So with all of this in mind, if I've got a sugar problem or if I've got an addiction problem, what is the remedy?
I will tell you that this is one of the things I did in my obesity clinic. So the only way you're going to be able to fix the problem is
I see messages all the time in the comments section that some of you didn't realize you didn't subscribe. So if you could do me a favor and double check if you're a subscriber to this channel, that would be tremendously appreciated. It's the free thing that anybody that watches this show frequently can do to help us here, to keep everything going in this show in the trajectory it's on. So please do double check if you subscribed. And thank you so much, because in a strange way, you're part of our history and you're on this journey with us. And I appreciate you for that. So yeah, thank you.
Dr. Robert, good to have you back.
Oh, my pleasure.
I am particularly fascinated by this term, hostage brain. I know you're in the early stages of working on a book about this subject, but for anyone that doesn't understand, so when I look at this word, the hostage brain, I think of all the times that I've been out of control. And when I say out of control, I'm going to let you define it, but when I say out of control, I mean there's so many things I want to do as it relates to my health, my fitness, other aspects of my life, whether it's avoiding eating the cookie at 2 a.m. in a hotel room somewhere, or other areas of my life where I want to have greater elements of control. What do you mean by the hostage brain?
All of us want to be in control, Stephen. I mean, it's the nature of humanity. We want to be in control. We want to be in control of our lives. Unfortunately, many of us want to be in control of everyone else's lives, as we've seen play out on grand stages lately. Okay, everyone wants to be in control. And the reason we want to be in control is because then we can mitigate threat. When you're in control, then threat is low because you're in control. Problem is, we're not in control. The more in control, the more a specific area of your brain is basically glomming on. And that area of the brain is known as the amygdala. The amygdala is your fear center. It's also your 24-hour sentry. But really what the amygdala is, it's the point guard on your basketball team. Okay? So it surveys the entire court, sees the offense and the defense, and has to make split-second decisions. Who's going to score? Now, a lousy point guard takes all the shots. A good point guard passes off to the guy who has the best shot. A great point guard is going to be able to figure out if he's going to score or if he's going to pass it off to somebody else. If you're in control, okay, your level of threat goes down. But really, your control is an illusion. You really don't have control. And the more you try to exert it, the more you realize you're not in control. And what that does is that generates an enormous amount of stress and an enormous amount of pain. Now, that pain can turn inward, and we call that depression. And right now, 29% of Americans are depressed, and 4.4% of the entire world is depressed. These numbers were infinitesimal a generation ago, and they are basically, just pushing up further and further. And the reason is because of this inappropriate illusion of control. And it's causing an enormous amount of pain. How do you mollify that pain? How do you basically deal with the psychological pain of lack of control that you yourself put upon yourself? Well, we have loads of ways. Cocaine, amphetamine, nicotine, alcohol, sugar, gambling, social media, internet gaming, pornography. Pick your poison. That's dopamine. Dopamine basically provides you with a little bit of pleasure on top of a whole lot of pain. The problem is that dopamine is addictive. And so when you apply a set of pleasures to try to deal with your pain of lack of control, that puts you into a never-ending cycle of consumption and misery. That's the hostage brain.
What do I need to understand about dopamine in order to, because I think sometimes awareness is step one in being able to do something about a problem that you might have. So what do I need to understand about what dopamine is and what it's doing in my brain and how it's sort of associated with addiction to then be able to do something about it, which I consider step two?
So dopamine basically has two functions. The first is learning. There's no learning without dopamine. Anytime you learn something, whether it's positive or negative, it's because there was a dopamine release. When you put your hand down on a hot stove when you were 3 years old and went, I'm never doing that again. Okay, that was dopamine that did that. Okay, and what it did was it went to your amygdala and it rewired it. That was a rewiring of your amygdala due to the excitatory neurostimulus of that dopamine affecting an area of your brain called the basolateral amygdala. Okay? And it laid down and it set up a circuit, and that circuit is still working in you right now. Okay? So dopamine is the learning neurotransmitter. It can be for negative learning, it can be for positive learning. Either way. Dopamine is also, when it's going to another area of the brain called the nucleus accumbens, which is the reward center, that is a stimulus for reward. That is the motivation for reward. That is, in one word, foreplay. Okay? That is the excitement, the reason for continuing any given behavior. Okay? You get both out of dopamine. Okay? And in short, small bursts in the right venue, that's how we navigate life. We navigate it through learning and we navigate it through reward. You can't do it without dopamine. Dopamine is good, unless it's bad. And as you know, everything in science is both good and bad. The problem is chronic overstimulation of any neuron leads to neuronal cell death. Dopamine is a chronic stimulator. And so if you have chronic dopamine being released, what's going to happen is you're going to kill the next neuron. Now, that neuron doesn't want to die. So it downregulates the receptors for dopamine so that it's less likely that one dopamine over here is going to find the receptor over here to bind to because there are fewer of them. So what this means is more and more for less and less. And we call that phenomenon tolerance. More dopamine, more tolerance. So the law of diminishing returns. So you get a hit, you get a rush.
Could be a sugar, alcohol, whatever it might be. Pornography, yeah.
Pick your poison, doesn't matter. You get a hit, you get a rush, receptors go down. Next time you need a bigger hit to get the same rush, receptors go down, and then you need a bigger hit and a bigger hit and a bigger hit until finally you get a huge hit to get nothing. That's called tolerance. And then when the neurons actually start to die, that's called addiction. So tolerance is the start of addiction. And the problem is more dopamine, more tolerance, more addiction.
So people that are getting addicted to unhealthy foods and sugars and those kinds of things, What's like going on in their brain?
So at first, the first time they taste it, whatever it is, whether it's a Fruit Loop or candy corn or Frappuccino or pick your poison. You get this big sugar bomb going off in your head, and you go, "Wow, this is great! I want some more of this."
And what is that?
And then you
sugar
down
bomb?
the whole Frappuccino, okay. And what you've done is you've basically hit your nucleus accumbens with a big slug of dopamine, and you go, "Wow, that was great." And then an hour later, it's gone, and then you go, "God, I need that again." Okay? So the first time you got it, you liked it. The second time you did it, you wanted it. And the third time, you needed it. So that's the difference between liking and wanting and needing. Okay? Because liking, we all do. And no one wants to take away liking. Wanting gets into problems because you can abuse things. Needing is when you actually have a biochemical and medical problem.
So with all of this in mind, if I've got a sugar problem or if I've got an addiction problem, I'm addicted to insert poison, what is the remedy? Just avoid it for a while? And then if that is the remedy, what's going on in my brain? Is it fixing itself?
There are many remedies, okay? And they can all be used in conjunction with each other. Ultimately, the only thing that's going to work is getting those dopamine receptors back up. Remember, I told you dopamine downregulates its own receptor. The only way you're going to be able to fix the problem is for the dopamine receptors to come back up. There's a trend going on right now out in Silicon Valley you may have heard of called dopamine fasting. Okay.
Yeah, I've heard the word.
Basically, people lock themselves up in a hotel room for 3 weeks. Okay, don't take a shower, and basically, take the TVs out of the room, and try to commune with themselves and with nature, with no stimuli, with no external stimuli, in order to bring their dopamine receptors back up. Particularly true of cocaine addicts because their dopamine receptors are way down because, after all, cocaine is a dopamine reuptake inhibitor. So it's flooding the zone with dopamine. Therefore, those receptors are, down in the sewer. Now, do you have to be that severe? No, of course not. But does it work? It takes 3 weeks. You want to do it for 3 weeks? Yeah, then it works. Other ways. You can wean yourself off. You can do abstinence. And if you can do abstinence, that's a good idea. Hard to do, especially when it's, staring at you and when it's available 24/7, 365, like sugar is. It's everywhere. It's on every street corner.
Well, when I fast or when I do the ketogenic diet, I lose my apparent cravings.
That's right. Exactly right. And the reason is because no sugar in a ketogenic diet. So you're basically removing the offensive stimulus.
I was so shocked. I love those cinnamon roll things. Not that I probably eat one every 2 years, but I love them nonetheless. I'm like a big admirer, even though we don't have a relationship anymore. And when I did the ketogenic diet for I was 4 weeks in of not having any sugar or carbohydrates. And I walked up to this concession in Cape Town with all these amazing cinnamon rolls. They're like specialists. And I looked at them and there was zero part of my brain that was interested in any of it. Zero part of my brain. And I was like, wow, my brain has been like rewired or something just because I've removed sugar from my diet.
Yeah. It happens, but it takes a while. It's not something that, you can turn on and off. Okay.
Yeah.
It takes a fair amount of time. I will tell you that, this is one of the things I did in my obesity clinic, on a daily basis, was getting people off their sugar addiction.
How did you do that?
Sometimes you have to basically babysit them. You have to, work with them and work with their parents in order to, basically turn over the entire pantry, because the sugar is hidden in all the foods. I mean, there are 262 names for sugar, and the food industry uses all of them. This is why we are trying to get sugar addiction and ultra-processed food addiction codified by the WHO and by the American Psychiatric Association as a bona fide diagnosis so that we can get remediation and therapy for people.
One of the things that was one of the most popular parts of our conversation last time, Robert, was there's a section where we talked about the different types of sugar and Diet Cokes and Coke Zeros and all these kinds of things.
Yeah.
You know, I can see a couple of cans on the desk over there where Jack is in the darkness that I can vaguely see. And these cans of fizzy drink, they all have some kind of sugar substitute.
Yep.
Are those sugar substitutes harmless?
No, of course not. A paper just came out like 3 days ago in Annals of Neurology, basically showing that non-nutritive sweetener consumption, so diet sweetener consumption, correlates with dementia. And we think we know why.
Why?
Reactive oxygen species, so oxygen radicals, little chemicals that are given off from various substances that cause changes in energy metabolism in cells and also cause damage in cells. ROSs, reactive oxygen species. The famous ones are aspartame and sucralose. Now, do monk fruit extract, do stevia, does allulose also cause reactive oxygen species? I very specifically looked for data on those, could not find it. But for aspartame and for sucralose, the two biggest ones that are available today, the ones that are used in a lot of diet drinks, huge amounts of ROS generation.
ROS?
So, reactive oxygen species generation. So anything that generates ROSs contributes to dementia.
Is the evidence strong at this stage?
Yeah, it's pretty darn strong. I'm actually giving a talk about this next week in San Diego.
I heard you've got a new theory on the causes of Alzheimer's dementia that's somewhat linked. This is it.
This is it. Yeah.
Can you explain that to me? And you've not talked about this publicly yet. You're set to talk about it in a couple of days, I hear.
Let me take it back a step. Okay, there's this organelle inside our brains called mitochondria. You've heard of mitochondria.
Yeah.
For your audience, mitochondria are the little energy burning factories inside each of our cells. What they do is they take food energy and turn it into the chemical energy that your cell can actually use to power itself. Okay? And that chemical energy has a name. It's called ATP. Now, if you took biology in high school, you've heard of ATP, adenosine triphosphate. The energy is in the phosphate bonds. So ATP will give up its energy and go to ADP, diphosphate, which will then give up its energy and go to AMP, monophosphate, which will then finally go to adenosine. And adenosine binds to the adenosine receptor and makes you go to sleep. Mm-hmm. By the way, that's where caffeine works. It blocks the adenosine receptor, keeping you awake so that the adenosine can't bind to the adenosine receptor. Okay? So that ATP is the currency of the cell. That's what makes the cell run. Anything that depletes ATP is going to put the cell at risk. Mm-hmm. Okay? Because it doesn't have the energy it needs to run.
Yeah, it's gasoline.
It's like gasoline. So what happens when you start running out of gasoline? Well,
you break down.
You'll break down. So brain fog, difficulty concentrating, irritability, and ultimately all the way to depression. So the amount of ATP within any given neuron is the proximate cause of neuronal dysfunction that we see as neurocognitive and neurobehavioral change. Now, how do mitochondria and how do ROSs fit into this? Mitochondria make ATP, but every time they make ATP, they also make ROSs. There are 11 steps in mitochondria, and they all give off ROSs. Now, those ROSs are going to damage the cell. They have to be gotten rid of. They're like toxic fumes. They got to be gotten rid of. And so we have a pathway in each cell of our body to get rid of the toxic ROSs. Okay? They're called antioxidants, like glutathione, vitamin E, vitamin C, a host of other flavonoids. Okay, those basically quench those reactive oxygen species. They go to die. If you do that, then the ROSs basically just get funneled away and all is well and the cell can keep working. But if for some reason those antioxidants aren't up to par, if, for instance, you've been eating ultra-processed food and you can't make your antioxidant complement, then the ROSs feed back. And what happens is the ROSs are basically telling the cell, hey, you're shunting too much energy down this pathway because I can't clear them. So there's too much stuff. So shut it down. And so what happens is that instead of funneling the glucose into the mitochondria to generate more ATP, it diverts it and it goes off into other directions like glycogen, which is in the brain is not good, or fat, which is even worse. And bottom line, your cell is now not energy producing like it used to be. It has now been reduced in terms of its energy capacity. What's that going to do? That's going to reduce ATP generation. Okay, that's step one. Now step two. There's this stuff called cortisol. Cortisol comes from stress. Cortisol comes from sleep deprivation. Cortisol comes from exogenous glucocorticoids, like steroids being given to people for, autoimmune disease or for, other illnesses. Okay, that cortisol causes neurons to increase in metabolism, causes them to burn energy faster. Okay, so now you have an increased ATP utilization. So you have a decreased ATP generation. Now you have an increased ATP utilization. Now you've got an energy crisis inside each cell. Now your ATP can't keep up with the needs of the cell. And when that happens, now you've got symptoms, whether it's brain fog or irritability or all the way to frank depression. Okay, now, step three. There are these proteins inside each neuron called amyloid precursor peptide, APP. Okay, it's a normal protein in all cells. Every cell in your body has APP. It needs to stay in solution. And in order for it to stay in solution, energy has to be applied to it in order to keep it in solution. The minute the ATP in the cell goes down, they come out of solution and they start forming aggregates, which we call plaques.
Yeah.
Okay? And those plaques damage the cell, which then start an inflammatory process in the cells next door called the microglia in order to clean up the process. And now you've got plaques and an inflammation, and now you've got neuronal cell death. That's dementia. So it starts with an ATP energy crisis, moves through plaque and inflammation to generate neuronal cell death. Well, this is problematic to say the least. And by the way, anything that generates ROSs has been associated with Alzheimer's. Anything that increases ATP utilization, like stress, glucocorticoids, fever, autoimmune disease, also increases Alzheimer's. So anything that increases step one, anything that increases step two, ultimately leads to increased step three and Alzheimer's.
So to simplify this in a couple of sentences for someone that has no scientific understanding, and we're going to have to cut a few corners here scientifically in order for them to have a framework to understand it. How would you give me some sort of an analogy for it? Maybe in the context of, I guess, a petrol station and a car.
Yeah. So, I mean, if we're basically doing petrol, we're talking energy only.
Yeah.
Okay. So bottom line, your car runs